Assalamualaikum, my name is Diana. In this video, I am going to show you how to answer question 1 chapter matter from College Matrikulasi Kedah 2022-2023 set 4. We start with question 1. The question provides us the percentage of relative abundance and mass of isotope of an element, and we need to calculate the relative atomic mass. So first, we need to calculate the average atomic mass to get the mass of one atom of the element. This is the formula of average atomic mass. Qi is the percentage of relative abundance, while Mi is the mass of the element. When you are substituting the value into the formula, make sure it is in the correct pair. So we all know the whole percentage is 100, so we just subtract 100 with the 57.4%. So we got 42.6 for the second. Then we got the answer 121.7560 AMU. Next, we substitute the answer into the relative molecular mass formula to cancel off the unit. So the final answer is 121.7560. For mass allocation, 1 mark for the average atomic mass formula or the substitution, 1 mark for the answer with the unit, and lastly 1 mark for the final answer. The total marks is 3 marks. For question A2, we need to identify this element in the periodic table. So we need to refer the table of relative atomic mass. We need to search the element with the relative atomic mass 121.76, and it is antimony or SB. 1 mark was given for the correct element. Moving to question B1, we need to write a balanced equation based on the information given. Make sure the equation is balanced. Then question B2, if 8 times 10 power of 4 kg hematite was consumed, calculate the mass of iron produced. First, we need to convert the mass of Fe2O3 into moles by using the moles formula. So we can do a CheMaTriQue based on the balanced equation. 1 mole of Fe2O3 reacts with 2 mole of Fe. Make sure to use triple equal signs, that means equivalence. After calculating, we got the mole of iron. The question asks for the mass of iron, so we substitute the answer into the formula of mole. The final answer is 5.597 times 10 power of 7 gram. You can convert it into kilogram also. Mass is given 1 mark for the balanced equation, 1 mark for the answer of mole of Fe2O3 with the unit mole, 1 mark for the correct CheMaTriQue, 1 mark for mole of iron with the unit mole, and 1 mark for the final answer either in gram or kilogram. Total mark is 5 marks. For question C, the question provides us a balanced chemical equation, and the question provides us the mass of sodium bicarbonate and mass of citric acid. Question C1, determine which substance which is the limiting reactant. So we need to find the mole of citric acid and sodium bicarbonate by using the formula of moles. Both of these moles is the moles that are available for the reaction. So now we need to find the needed mole. Based on the balanced equation, I'm doing the CheMaTriQue. 3 moles of NaHO3 reacts with 1 mole of C6H8O7. I'm using the moles of citric acid to find the needed mole for sodium bicarbonate, and I got 0.0156 moles of NaHO3. And then I compare the moles of NaHCO3 needed with the mole of NaHCO3 available. So, since the mole of NaHCO3 needed is more than mole of NaHCO3 available, thus NaHCO3 is the limiting reactant. For mass allocation, 1 mark for answer both mole of sodium bicarbonate and citric acid, 1 mark for correct CheMaTriQue, 1 mark for mole of sodium bicarbonate needed, 1 mark for compare mole needed and available, and lastly 1 mark for stating that sodium bicarbonate is the limiting reactant. For question C2, how much of the excess water remains in grams after the limiting reactant is completely consumed? For this question, we just do a stoichiometry to find the mole of citric acid needed. Since we already calculate the moles of sodium bicarbonate available in question C1, we just substitute it and we got the mole of citric acid needed. Then we subtract the mole of citric acid available for question C1 with the mole citric acid needed to find the balance of citric acid. Lastly, we convert the mole into the mass in grams. For mass allocation, 1 mass for moles of citric acid remains and 1 mass for mass of citric acid. Lastly, question D provides us the balanced chemical reaction, the actual yield and the percentage yield of potassium chlorate. We need to calculate the mass of oxygen gas required. So first step, we need to find the theoretical yield by using percentage yield formula. Then we got 4.42 gram. Then we need to convert the mass into the mole for the stoichiometry. Next step, we compare the mole of potassium chlorate with the mole of oxygen by using stoichiometry. Then we got 0.045 mole of O2. The question asks for mass, so we need to convert it into mass by using the formula. For the mass allocation, 1 mark for the formula of theoretical yield or the substitution, 1 mark for the answer for the theoretical yield, 1 mark for the number of mole of potassium chlorate, 1 mark for the mole of oxygen, and lastly 1 mark for the mass of oxygen required. That's all from me. Thank you for watching.